Let's go through this one over here now. So the first thing here in this bracket, what I'm going to do is simplify this bracket over here. So we're doing algebra revision, okay? And 2 can go into 4 two times. I'm going to rewrite this bracket. Keep the squared on the outside, but try and simplify the inside first. That's going to become 2 in the denominator from 1 over 2. I could put the 1 at the top as well if I need to. X cubed, I have nothing to simplify it with, so I'm just going to rewrite that. Y squared, we've got 2 at the top and 1 at the bottom, so we have 1 extra at the top. I have 1 z at the top and 4 at the bottom, so I can cancel out one of them at the bottom, leaving me with 3 at the bottom. 4. 1 minus 4 is negative 3, which is positive in the denominator. Alright, so that's z, 2z cubed. The next thing I'm going to do is distribute the 2 to every single power, multiplying each power by 2. Given the numbers, multiply each of the numbers by 2. I'm going to get 1 squared, which is 1, right? X to the power of 3 times 2 would be x to the power of 6. Y to the power of imaginary 1, 1 times 2 is 2. 2 squared is 4. Z to the power of 3, 3 times 2 is going to get me 6. And that's my final answer. So just multiplying each power by 2. The other way is that because it's squared, I can actually just write it twice. I can write x cubed y over 2z cubed, x cubed y over 2z cubed. If I multiply that across, I get x to the power of 6y squared, and 2 times 2 is 4, z to the power of 6. Anyway, so I could possibly do method number 2 and write them twice and multiply each variable separately, one at a time, and numbers and variables in the denominator as well. Question 2, simplify the following. We've got to think about some business, but we also got to look at division different times. Now, BidMass says that over there is what I need to get to. So 12 over x is going to multiply to get x squared over 4, and that's going to be tipping times. Tipping the right fraction over and multiplying it. X goes into x squared once, 4 goes into 12, 3, minus 16. We have 3x over there, minus 16x. So 3x minus 16 using integers is negative 13x. Final answer there, negative 13x. Expanding the following, I'm going to leave the 2 for last. And over here, I'm going to use the method of FOIL, where I multiply first, outer, inner, last. That gets me 2x squared, 8x, but a negative, plus x. And you can see these two are like terms, which will simplify to negative 7x in the next step. And the last one, 1 times negative 4, negative 4. So bringing down those last and first terms, 2x squared minus 7x minus 4. All right, and that's going to be the final answer before. Actually, I've still got to multiply it by 2, right? So let's not forget that part there. Okay, so I have 8x minus 4, 2x squared minus 7x minus 4. But the 2 is still on the outside. I haven't multiplied that in yet. Now I'm going to multiply the 2 in by every single term. That's going to get me 4x squared minus 14x minus 8. Final answer there, 4x squared minus 14x minus 8. If a is equal to negative 4, we're doing some substitution now, and b is equal to negative 2, and c is equal to 3, calculate 3 significant figures, obviously using a calculator, and substitution. So negative 4 squared, b squared is negative 2 squared, minus a times c, which is negative 4 times 3. That'll be 16. That'll be 4. Minus times minus is plus 12. And in this case, it'll be 16 multiplied by 4 plus 12 is 16. And that's actually going to get you 16 times 4, because the square root of 16 is 4, and 16 times 4 is 64. The three significant figures means I have to put a .0 at the end. That's what three significant figures is. 64.0, the three significant figures. For question number 4. All right, let's run through these now. The first one here, when you've got a fraction equal to a fraction, and there's no other number added onto it, and you want to solve for x in this case, the best way to do this is to cross multiply. So we would bring the 4 to the top left-hand side, and bring the 2 to the top right-hand side over there. Multiplying and bracketing, 4x, don't forget to multiply twice. So 4x plus 20, and then 2x plus 6. Then we subtract 2x on the left-hand side, and we subtract 20 on the right-hand side. 4x minus 2x gets me 2x, and 6 minus 20, negative 14. Dividing by 2 on both sides gets me x equals to negative 7 from there. Question 6. Solve for x and y. Simultaneous equations. I would add these two together, because if I do that, that will eliminate. Or I could subtract them. If I subtract them, x eliminates. Alright, I'm going to add them. X plus x is going to become 2x, and the y's eliminate. 4 plus 6 is 10. I divide both sides by 2, and I get x equals to 5 for this one. Substitute x equals to 5 into, let's say, the first equation. I have 5 plus y equals 4, and then 4 minus 5 equals y, so y equals negative 1. And now solve for x and y. Remember, that's a coordinate, which can be written as 5, negative 1, and it's also the intersection of these two equations. All right, the one is a negative line, the other one is a positive line, and they would intersect with the intersection of either negative 1 from. Okay, factorizing the next one, I can divide both terms by 3, and I can also divide both of them by x, which means I can take 3x as a common factor out. When I divide by 3, the 3's cancel out. When x goes into x squared, I'm left with x. When 3 goes into 9, I get 3, and x cancels out there, giving me negative 3. I'm done. Now this is fully factorized. If I just did 3 and I left out the x, it would be half factorized. Okay. Next one, I've got 8 plus 9, which is equal to 17. X to the power of 8 plus 9. When we multiply like bases, we add the powers. So this is going to be x to the power of 17. When we divide, we subtract. So this will become x to the 18 minus 20, which is x to the negative 2. If you have a negative power, bring it into either the numerator or the denominator, depending which side it's on. At the moment, it's in the numerator, because this is imaginarily over 1. So I bring it into the denominator, it will become a positive power, but then the numerator takes on the value 1. I'm left with 1 over x squared. Another way to see this is if you've got x18 over x20, you've got 2 more x's at the bottom. And it's as simple as that. So you can cancel out and have 2 more left at the bottom. Okay. When you have a power on the outside of the bracket, you multiply it by every single value on the inside of the bracket. And that's going to become x to the power of 2, y to the power of 4, and z to the power of 2. And that's going to be that answer over there.